Okay, let's try another sample combination circuit problem. So this one looks a little bit different than the last one, and I've gone ahead and I've labeled the voltage across the power supply as well as the resistance of each resistor. So now for the hardest part, which is identifying what things are in series and which resistors are in parallel. So it's pretty clear you have to go through R1. It's pretty clear that you have choice about going through R2 or R3 or this last path, which includes R4 and R5. But if you go through resistor 4, do you have to go through resistor 5? The answer is yes. And if we don't have choice, so if I go through resistor, I don't have a choice, I have to go through resistor 5, that means resistor 4 and resistor 5 are in series. So I'm going to isolate them as a series circuit. So I'm going to construct a green box around them. I'm going to put an S for series like we've done in previous problems, so we remember when we go back through the rules. And I'm going to put V, I, and R. Now remember your rules for resistors in series. Remember the mnemonic device, Vir Sacca Picara. So we'll write that on the side again. And that'll help you keep your rules straight. So we're looking for resistance in series. We can see that they add. So let's just go ahead and add 8 plus 16. And we can see that it is 24. So I'll put that here at 24. Got cut off a little bit. So now we are going to pretend that that green box is simply one resistor. So the next thing is you go back to R1 and you say, okay, if I go through R1, which I know I have to go through, I could either go through R2, R3, or this green box. So I have three choices there. That means that those three resistors, R2, R3, and the green box, are in parallel. So let's construct a box around those to indicate that they are in parallel. And so they are a parallel circuit. We're going to put a P up here to indicate that. And we're also going to put V, I, and R. So I have a 12 ohm resistor, an 8 ohm resistor, and a 24 ohm resistor in series because we're treating R4 and R5 as though they're one resistor. And so the rules for resistors in parallel is that reciprocals add. So let's go ahead and add the reciprocals. So we're adding 12 to the negative 1 plus 8 to the negative 1 plus 24 to the negative 1. We press enter. We get 0.25. And then, of course, we have to take the reciprocal of that, which is going to give us 4 ohms. So now if you think about this circuit as a whole, we've reduced it to be a series circuit. In fact, we've reduced it to be a series circuit with just 2 resistors. And what are those 2 resistors? So we still have, I'll draw it on the side, we have our 48 volt power supply. We have R1, which is a 2 ohm resistor. And then we have the green box, which is we have the purple box, which is a 4 ohm resistor. So we've reduced this entire circuit to be a series circuit with 2 resistors. And those resistors are R1 and the purple box. And you can see that because they're in series, we're going to follow the rules for resistors in series, and that is that they add. So 2 and 4 is going to give us a total resistance for the entire circuit of 6 ohms. We can now use the table to find the total current. So we have 48 volts divided by 6 ohms will give us our total current, which is 8 amps. So that means that we're going to have 8 amps coming out of the power supply. Where must all 8 amps go? Well, they certainly have to go through R1. So we'll put 8 amps in R1. They must also go through the purple box. So I'm going to put in 8 amps here as well. And is there anywhere else all 8 amps must go? No, because remember, we've reduced it to be just this series circuit off to the right here. And so the only place all 8 amps have to go is through those elements, R1 and the purple box. And so it's like a puzzle. So we know the current in the purple box is 8, the resistance in the purple box is 4, voltage in the purple box has to be 8 times 4, or 32 volts. The purple box was what kind of circuit? It was a parallel circuit. Well, in a parallel circuit, what's constant? So go to your Veer-Sakopekara chart. In parallel, your constant is voltage. So everything that was in parallel, R2, R3, and the green box all have to get 32 volts. We can fill that in the chart as well. And now what's the next piece of the puzzle? Looking inside that green box, you know voltage, you know resistance, so you can simply do 32 divided by 24 to get your current, which is 1.33. Repeating. So we'll fill that in the green box there. The green box was covering a what kind of circuit? Series. So what's constant in series? Current is constant in series. So this 1.33 amps has to be the same for R4 and R5. And we can fill that in on the chart as well. And now it's just a matter of going through and filling out the table. So 32 divided by 12 is going to be 2.67. And 32 divided by 8 is going to be 4. So you can see we now have something in either the voltage column or the current column. And so we should be able to go through and complete the table. So let's go ahead and do that. 2 times 8 is going to be 16. 16 times 1.33 is going to be 21.28. 10.64. And then now we can go ahead and try our power column. And so I've completed the power column, and you can see that we get about 383.89. And if we were to multiply to do our power check, the 48 times the 8, we would get 384. Now, because we had a bunch of decimals in this problem, we could be off slightly with the rounding, but we're going to consider that a power check. And there it is, another combination circuit example. Make sure you understand the entire process. You absolutely need to know these rules in the Veer-Sakopekara chart here. Can't do anything without knowing those rules. Hope this was helpful. Welcome back. We have a fourth example of a combination circuit that we're going to go through and we're going to analyze using our rules. So let's start by go ahead and labeling the resistance of each resistor. So at this point, if you're feeling comfortable with analyzing combination circuits, I want you to go through and I want you to construct boxes for this circuit. So you're going to combine things that are in series, combine things that are in parallel, until you've reduced this into a series circuit. So why don't you take a minute to do that? Okay, so I'm going to go through and I'm going to show you how I combine them. So the first thing I combined was R4 and R5 because I saw them as being in parallel. And we know resistors in parallel, the reciprocals add. So I'm going to add 10 to the negative 1 plus 15 to the negative 1, all to the negative 1, and that's going to be 6 ohms. I know that this teal resistor that I just constructed is in series with R2. So if I go through R2, I have to go through that other resistor. So these are in series. Resistors in series add. So 4 plus 6 is 10. Now, looking at that orange box, I would say that I'm going to pretend it's just one single 10 ohm resistor, and it looks to me like that orange box is actually in parallel with the other 10 ohm resistor, R3. So this was a parallel. For resistors in parallel, reciprocals add. So 10 to the negative 1 plus 10 to the negative 1, answer the negative 1 is going to give you 5 ohms. And so, looking at it, we've now reduced this entire circuit to a circuit with 3 resistors. R1, the purple box, and R6. And so I can simply add them up. 3 plus 5 plus 2 is going to give me a total of 10 ohms of resistance for the entire circuit. So if I know my total resistance is 10 ohms and my total voltage is 60, I simply divide 60 divided by 10. My total current for this circuit is 6 amps. So if I have 6 amps coming out of the power supply, where must all 6 amps go? All 6 amps must go to R1. All 6 amps must go to the purple box, so not anything that it's covering up, but the purple box as a whole. So in this, on the right there, I'm going to put the 6 amps, and R6 has to get 6 amps. So what's the next piece of the puzzle to fall? Well, in the purple box, if I know current, I know resistance, then I know my total voltage is 30. What's the rule for voltage in parallel? It's constant. So that 30 volts has to apply to everything that the purple box was covering up. And if you remember, the purple box was covering up 2 things. It was covering up R3. That must get 30 volts. And the other thing it was covering up was the orange box. So I'm going to put 30 volts in there. Looking within the orange box, we can see that if we have voltage and we have resistance, we can find the current. and the current there is 3 amps. So the orange box was a series circuit, and what was this series circuit covering up? Well, it was covering up R2, so that must get 3 amps, and the teal box, so I'm going to give 3 amps to that as well. And the teal box was covering up R4 and R5, which were in parallel. So I'm going to need the voltage there, which is going to be 18 volts. And I know that in a parallel circuit, voltage is constant. That means the 18 volts is going to apply to R4 and R5. So now I can just go ahead and fill that in the chart. So R4 was 18, R5 was 18, R2 was the 3 amps, and R3 was the 30 volts. So now I can just go through and complete the table, and then we'll do the power check. So 6 times 3 is 18. 4 times 3 is the 12. 30 over 10 is 3. 18 over 10 is 1.8. 18 over 15 is 1.2. And now I can complete the power column. So I've multiplied my voltage in every row times the current in every row to get the power in every row. And now I just have to add them up. Remember, we add down. And if what we get with our sum is the same as when you multiply total voltage times total current, then we have completed our power check. So we're looking for it to add to 360. It looks like. So it added to 360 and it multiplies to 360. So we have a power check to check. So the hardest part is setting up the boxes correctly, because you have to make sure you're correctly combining things that are in parallel and things that are in series. So I can tell you right now that one of the problems that some kids will have had in this particular circuit is they would have said that R3, R4, and R5 were in parallel because they're geometrically parallel. And that is not correct, because this parallel in terms of circuits and electricity has nothing to do with how they're laid out on the circuit diagram. It has only to do with whether or not there is choice about going through a specific resistor. I hope this was helpful.